Welcome to Lionhearted Academy. This is Richard Tai. We're on our 17th lesson of trigonometry. Today the focus is going to be on the functions of special angles and function quadrant angles. Now we actually have talked about some of the special angles before. Now the special angles are going to be multiples of 30 degrees, 45 degrees, and 60 degrees in each quadrant. There are three angles like that. They're multiples. They're related to 30, 45, and 60 in each quadrant. Quadrant 1, 2, 3, and 4. So today we're going to look at that. Now before we start, let's go ahead and start with 45 degrees. Okay, just review of what exactly was 45 degrees. Now 45 degrees is half of 90 degrees. Okay, so we look at our quadrant here from 0 to 90. That's half of 45. So this red line is halfway between 0 and 90 degrees, represents 45 degrees, or another way to write it is pi over 4. Okay. Now I think we talked about the measurements of the functions 45 degrees back then a few videos before. Okay, so 0 degrees is 0 radian, 362 pi, 90 degrees is pi over 2, 180 degrees is pi radian, and 270 degrees is 3 pi over 2 radians. But in any case, we did talk about the sine and cosine value of this 45 degrees angle. So we can take a look today and how this extends to everything else. How they extend to the same angle in second quadrant, third quadrant, fourth quadrant. Okay. So let me go ahead and construct that for you in a minute. Okay. All right. So that's the So there are four angles out there that in each quadrant has a reference angle of 45 degrees. Now here it's going to be halfway between 90 and 180, so that's 135 degrees. Here it's going to be halfway between 180 and 270, so that's going to be 215 degrees. 225 degrees. It's 180 plus 45, so 225. And here it's going to be halfway between 270 and 360 degrees. So 270 plus 45 is 315 degrees. Okay, so those are the special angles that's related to 45. Remember how we calculate reference angles? It's the acute angle between the terminal side and the x-axis. So this reference angle for 135 is 45. Now, but because 135 is in the second quadrant, so we can relate sine of 135, okay, directly to sine of 45. Now why is that true? Because sine in the second quadrant is always positive. Remember using the reference angle? But cosine of 135 should be an opposite, should be negative of cosine of 45 degrees. So we're doing the same thing using our reference angle, but we're just trying to build a repertoire for our special angle here. And then tangent of 135 degrees. Now a tangent in second quadrant is also negative, so it should be negative tangent of 45 degrees. Now if we go back to our tables before, sine of 45 equals to square root 2 over 2. I'm not sure if you remember that. You can go back to a few few lessons before. We used the right triangle to develop this. Negative cosine 45 degrees is negative square root 2 over 2, and negative tangent 45 degrees is negative 1. Okay, and let's do secant. Secant of 135 degrees is also negative, so it's negative secant 45 degrees, and that will be equal to negative square root of 2, and cosecant 135 degrees is going to be equal to negative cosecant, cosecant is positive because this is in second quadrant, so it would be positive square root 2. And then cotangent of 135 degrees will be equal to negative cotangent of 45 degrees, and it will be equal to a negative 1. So you can see what we're doing here is, if we know 45 degrees, then we can know the special angles 135, 225, and 315. Okay, so that's why we're going to use this. Now we're not going to do this for every one of them, because we understand the quadrant and their signs. Okay, if you don't remember this, you can go back to a previous video to review that. Alright, in quadrant 3, both sine and cosine becomes negative of quadrant 1 angle. So cosine of 225 will be negative cosine 45. Okay, but tangent of 225 is the same as tangent of 45. Now in quadrant 4, cosine remains positive, sine and tangent becomes negative. So sine of 315 is negative sine of 45, and cosecant of 315 is negative cosecant of 45. But secant of 315 is the same as secant of 45. So you just have to remember, that's why it's important to remember the sign of the quadrant, ASTC. Remember the acronym? All students take calculus, okay? All student takes calculus, I'm sorry. So ASTC. In first quadrant, everybody's positive. In second quadrant, sine and cosecants are positive. In third quadrant, tangent and cotangent positive. In fourth quadrant, cosine and secant are positive. Okay, so that's the basic layout again using the quadrant. So if you become familiar with those, it'll be very easy to determine the signs of and the relationship between the special angles with or any other angles with their reference angle in first quadrant. Alright, now let's go ahead and take a look at the 30 degree and then see if we can do the multiple of 30 degrees. So let's see if I can do a better job here. Alright, so 30 degrees about here. Okay, now 30 degrees and 60 degrees, they are actually multiples of each other. So in every quadrant there are two of them. Okay, I'm sorry, this I'm not drawing very not a very good job here, but alright, we're gonna figure them out in a sense. Okay, so this is 30 degrees. We're gonna do the radian a little bit later, but let's start with the degree first. 30 degrees, 60 degrees. So basically we're dividing the quadrant into thirds. So this is 1/3 of the first quadrant, this is 2/3 of the second quadrant of the first quadrant. So every division is 30 degrees, so basically we count by 30s. Okay, as you can see, 30, 60, 90. I think the next one is 120. Alright, the next one is 150, so that's what we count by 20. 180, then it's 210, you add 30, then you add 30 again, so 240, and you add 30, 270, you add 30, you get 300, and you add 30 again, you get 330 degrees. So this is the way to get all the special angles for multiples for 30 and 60 degrees. Okay, now let me go ahead and erase this part. Okay, alright, so now we can go ahead and take a look at 30, 60, and then all these multiple angles. So let's take a look at what are the reference angles for 30 degrees, okay? Or what are the special angles related to 30 degrees? So theta prime equal to 30, right? The reference angle equal to 30 are those which angles, okay? In quadrant 1, of course, it's 30, alright? But in quadrant 2 is 150. It's not 120, but 150, because 180 minus 150 is 30. So 150 is the reference has a reference angle of 30 in quadrant 2. In quadrant 3 it's going to be 210, and in quadrant 4 it's going to be 330. So those four angles are related to 30 degrees. Alright, so let me give you an example. So sine of 150 will be equal to sine of 30 degrees, because they are both in second quadrant. The sine is positive, and the first quadrant sine is also positive. So that will sine of 30 degrees will be equal to 1/2. Alright, what about cosine of 150 degrees? I'm not going to do every one, but I'm just going to give you a few examples. Cosine of 130 degrees is going to be cosine of negative 30 degrees, which will be negative square root 3 over 2. Okay, negative square root 3 over 2, which is the x coordinates. We haven't talked about that yet. When we get to, as you can see, we can use this to build something called unit circle in our next lesson. Alright, sine, cosine, and let's do one more. Let's do tangent of 150 degrees. Now tangent 150 degrees is the opposite, is the negative of tangent of 30 degrees. Okay, and negative tangent of 30 degrees is going to be negative 1 divided by square root 3, or another way to write it would be negative square root 3 over 3. Okay, alright, so And then we can definitely, let's try one for 210. Let's do secant of 210 degrees. Now in 210 degrees in quadrant 3, it is the opposite of secant of 30 degrees. Now secant of 30 degrees is 2 square root 3 over 3. So that's the opposite of 210. Let's do one for 330. Let's do cosecant. Okay, cosecant of 330 degrees happens to be negative as well. Negative secant of negative cosecant of 30 degrees. So it will be a negative 2. It will be negative 2. Okay, because its sine is negative 1/2, so its cosecant is negative 2. Alright, so we're done looking at the 30 degrees and the special angle. Now let me erase this, and let's go ahead and take a look at the special angles related to 60 degrees. Alright, now we're back. Let's go ahead and take a look at the theta equal to theta prime equal to 60 degrees. So which angles are related to has a reference angle of 60 degrees? Of course, the first quadrant is 60 degrees. The second quadrant is 120 because 180 minus 120, that's 60. So 120 degrees is related, it has a reference angle of 60 degrees. In third quadrant, it's going to be 240. And the last in third quadrant was going to be 300 degrees. So 60, 120, 240, and 300 all have the reference angle. They all have the reference angle of 60 degrees. Okay, so let's just do a few examples. I think by now you get the gist of it, but let's do a few examples. So let's try tangent of 60 degrees. I'm sorry, not tangent of 60. Let's try tangent of 120 degrees. So in second quadrant, tangent is negative, so it should be equal to negative tangent of 60 degrees. And what is tangent of 60 degrees? Well, tangent of 60 degrees is sine of 60 degrees divided by cosine of 60 degrees. So it's going to be a negative square root 3 over 1. Square root 3 over 1. Okay? Okay, what about, let's try another one for 240 degrees. Okay, what about tangent of 240 degrees? Well, tangent of 240 degrees is going to be positive tangent of 60 degrees. So it's going to be positive square root 3. Because in third quadrant, tangent is positive. Okay, what about secant of 300 degrees? Well, secant of 300 degrees is the same as cosine of 60 degrees. So cosine of 60 degrees is 1/2. Okay, so positive. Oh, okay. No, I'm sorry. I mean secant of 60 degrees. So cosine of 60 degrees 1/2, and secant is the reciprocal of that, so which is going to be 2. Again, so that's how we can relate every angle in this kind of relationship back to the first quadrant, 30, 45, and 60, using the reference angle relationship and the signs of the quadrant. Alright, so let's go on a little bit from here and let's look at the quadrant angles before we finish today. So what are the quadrant angles? The quadrant angles, there are 4 of them: 0 degrees, 90 degrees, 180, and 270. Well, there are actually more because it keeps going on. It's a cycle, it's a periodic function, so we'll talk about that as a periodic function, how everything repeats itself. But in the first, the quadrant angles are the angles that divide the quadrants. Okay, 0 degrees, 90 degrees, 180, and 270. And so we want to go ahead and understand how the angles, how the function of each function works. Well, remember we did one example before for 0 and 90 degrees, but let's go ahead and do for all of them. The key is to understand that using a terminal point, because the terminal point, the x and y point, determines this point, and the radius determines the functions of sine, cosine, tangent, and so let's say we set as equal distance. Let's call this distance r, which will be equal to x. So this point will be x and 0 here. Now let's go ahead and use the same r. Let's say we use the same r here, but this point should be equal to 0 y because there's no x coordinate here. Now if we use the same r again here for 180 degrees, this point would be a negative x and 0 because it's all going the same distance. Okay, x equal to r here, but it's actually the absolute value of x. Okay, so it's negative absolute value of negative x. Let's go ahead and rewrite that a little bit. Alright, so this is x equal to r. Here's y equal to r. Here's the absolute value of negative x is equal to r here. Alright, let's go down here and let's do absolute value of negative y equal to r. Okay, so we're going down negative y distance, but the r distance is positive here, so this is 0, negative y. So as you can see, now we have our x, y, and r for each of the quadrant angles that we can decide what the sine, cosine, tangent function of them should be. Okay, so let's start with 0 degrees. I think we did 0 degree before, but it doesn't hurt to do it again. So sine of 0 degree will be the opposite, or y over r. So in this case, it's 0 over r. So this is 0, right? Cosine of 0 degrees will be x over r, which is x over x, will be equal to 1. And tangent of the 0 degrees will be sine over cosine, or the y over x. So 0 over x equal to 0. Okay, and cotangent, let's go ahead and do secant first. Secant of 0 degrees, it should be the reciprocal of cosine, so it's 1, this is x over x. And then cosecant of 0 degrees will be equal to the radius over the y, so it's undefined. So there's no cosecant for 0 degrees. And cotangent of 0 degrees is going to be x over r, y, but y value is 0, so it's also undefined. Okay, so for 0 degrees, it looks like this. Alright, let's go ahead and do 90 degrees. So sine of 90 degrees, okay, take a look at this. Sine has an order pair of 0 and y, and then the radius is, of course, is r. Okay, we're using the same radius for all 4 angles here. So that is going to be y over r, but y and r are the same thing, so it's going to be 1. And cosine of 90 degrees is going to be 0 over r, so it's going to be 0 because the x coordinate is 0. Now tangent of 90 degrees is going to be y over x, but x is equal to 0, so it's undefined. So that's a very interesting point, because tangent of 90 degrees doesn't exist. Alright, and secant of 90 degrees is the reciprocal of cosine, which is r over 0, which is undefined because it doesn't exist. Okay, divided by 0 doesn't exist. Cosecant 90 degrees is r over y, so which is 1 because they're the same value. Okay, I'm sorry, I'm running out of room here, so please bear with me. Cotangent 90 degrees is going to be equal to 0 over y, so it came out to be 0. Okay, alright, what about 180 degrees? Or pi? Okay, sine of pi, sine of 180 degrees is going to be equal to 0 over y, over r, I'm sorry. R is negative x, but r is x in this case. Absolute value of negative x is just x, so it's still 0. The cosine of 180 degrees will be equal to negative x over r. Well, r is x, so negative x over x. So it's negative x over x, so it becomes to be negative 1. So there's a major difference here. For cosine of 180 degrees is negative 1. And tangent of 180 degrees will be equal to y over x. Now, x is negative x, so but even though it's 0 over negative x, it's still equal to 0. So the sign doesn't really care, doesn't matter in this case. But the secant of 180 degrees, it does matter. Secant of 180 degrees, it does matter. So it will be equal to r over negative x. Okay, so that will be negative 1 as well. In this case, r is equal to x. Cosecant 180 degrees is going to be equal to r over y. Y is 0, so it's undefined again. And the cotangent of 0 degrees, 180 degrees, is also going to be undefined, as you can see, because it's going to be negative x over 0, so it's undefined again. Alright? Alright, lastly, let's look at cosine of sine cosine of 270 degrees. So we're trying to just derive everything that we see here. So it's going to be negative y over r, which is going to be negative 1, because r is equal to y. Cosine of 270 degrees is going to be 0 over r. It's going to be 0. And tangent of 270 degrees is going to be equal to y, negative y over x, which is 0 is undefined. So 270 degrees, it doesn't have a tangent value. Secant of 270 degrees is going to be r over 0, so it's undefined as well. Undefined. Okay, and you can see some pattern here between 270 and 90, of course. It's going to be r over negative y, so it's going to be negative 1. And cotangent of 270 degrees is going to be 0 over negative y, so it's 0. Okay? Alright, so, and then when we go back to 360 degrees, we go back to the pattern of 0. And then you can keep going. Every time you rotate back to the quadrant angles, you follow this pattern. Alright, now you don't have to really remember this per se, but if you remember the chart, if you understand how we derive it, this is how you can derive it every time for yourself. Okay, you understand that x and y. So that's why next lessons we are going to talk about something called unit circle. And using a unit circle, you can derive this for everything. But this is a generic setting. This is just like the unit circle we're going to look next week. But this is generic. We don't have to limit r to any particular distance. I hope you enjoy our lessons next week. We'll see you next week in our unit circle lesson.